Proliferated LEO constellations are large-scale satellite networks working in coordination to provide robust mission assurance. The U.S. government, among others, has shown it sees pLEO constellations as the future of space architecture due to faster development lifetimes, diversified supply chains, and more robust coverage and resiliency. With this new architecture, there are new adversaries and threats that need to be considered, which we will cover in this video. One of the newer emerging threats faced by pLEO constellations comes from their ability for direct-to-device services, also known as Internet of Things. This direct connection to many individual devices opens new opportunities and accessibility for malcontents to exploit. With direct-to-device connection, individuals or groups of individuals can now introduce malware to satellite systems directly, or implement distributed denial-of-service attacks. A recent example of this is the DDoS attacks against SpaceX Starlink satellites that the Russia hacking group called Gronet claims to be behind. The next vulnerability for pLEO constellations is signal interception. Unlike direct-to-device originated attacks, this signal interception is aimed at spying on sensitive information meant only for transmission to a specific user or ground station. Since the satellite downlink can cover a wide footprint on Earth, a strategically placed receiver can intercept one side of the information as it transmits. An Oxford researcher was able to do just that, to eavesdrop on satellite signals using only $300 worth of satellite TV equipment. Jamming is another technique which is used by adversaries to deny the ability to communicate altogether. In close enough proximity, jamming can prevent communication nodes between satellites and ground stations from working, and prevent the ability for information transfer. An Iranian regime was using this method to prevent the free flow of information by jamming satellite TV broadcast satellites back in 2012. Remote proximity operations, or RPO, is an emerging technique made increasingly lucrative with new, highly agile LEO satellites. RPO involves an adversarial satellite coming within close proximity to another in order to disable a satellite or gather sensitive information. In early 2022, a Chinese satellite was able to approach another satellite and grapple it out of orbit. Ground stations and mission ops centers are also vulnerable links in the architecture and can be targeted for attack. Hacking to obtain data or control, malware to infect systems, or phishing to gather intel on personnel are all common vectors of attack on these systems. The Russian-originated attack on Viasat modems in the Russian-Ukraine conflict is an example of hacking and malware attacks on ground infrastructure. One advantage of pLEO comes from the diversified supply chain, which can be used for these satellites with shorter overall performance lifetimes. However, with expanded supply chain comes increased risk of the introduction of counterfeit parts going unnoticed, which in some cases can even carry Trojan horses once integrated into the system. An example of this occurred in 2012, where a batch of counterfeit electronic parts found their way into the Air Force's largest cargo plane and were earmarked for use in military assets. Finally, insider threats are something we must remain vigilant for, as individuals with sensitive access can distribute that information or introduce malware to systems from the inside. Most famously, Edward Snowden was an insider threat, but individuals like Chelsea Manning, who pioneered the largest known security breach by leaking documents to WikiLeaks, have the potential to severely hurt space systems by providing information to adversaries which could be exploited.
When it comes to defending the attacks that are especially concerning to pLEO constellations, that being via supply chain or through exploiting the vulnerability of common systems within a mesh network by using insider threat-borne malware, there are several cybersecurity interventions and methods that may be of help with the task. Attacking the supply chain to inject malware into the satellite system could be done by using a variety of methods, such as social engineering and phishing, large-scale network scans and intrusions, or by hacking the software that a supplier uses to develop products. Either way, malware finds its way into the spacecraft via software or hardware. To help prevent this, software source control is a method which allows suppliers to deliver source code instead of executable files that may hide malware. The source code can be studied to determine that it is free of malicious functionality. Otherwise, surveillance of suppliers, audits, and inspections of supplier facilities can help prevent the introduction of malware through mitigating vulnerabilities. Insider threats are particularly concerning to pLEO space systems as they are rather difficult to detect and can have catastrophic consequences. In an attack, a trusted member of an organization could use their status to exfiltrate engineering data and processes about a spacecraft or ground station network. By providing a threat actor with the information, hazardous targeted malware can be developed with a vast array of resources available. There are several methods to help prevent malware from reaching the spacecraft. From an external standpoint, a network firewall and physical security and digital surveillance can prevent intrusions. From the perspective of an insider threat, physical and digital access control makes sure that a particular individual only has access to the rooms, equipment, and information that they need to know to accomplish a job function, but nothing more. Network monitoring and forensics surveys an individual's actions to make sure that they are not accessing information or running processes that can be malicious in nature. If malware does reach a host spacecraft, there are a couple methods to aid in preventing the spread of malware through the crosslink antennas. Spacecraft onboard monitoring may detect malware depending on how it is configured. If malware is detected, the satellite could be put into a safe, non-transmissive state autonomously. Next, inter-satellite zero-trust security can be implemented, which uses identity verification, validation of satellite compliance, and the access of only necessarily privileges to specific resources. A satellite can be verified as safe before communicating with it via crosslinks, preventing the spread of malware.